Hi, welcome to today's educational program, the IIoT Attack Surface, Threats and Security Solutions, brought to you by IoT World and sponsored by Trend Micro. I'm Lucian Fogoros, I'm the co-founder of IoT World, and I'd like to introduce our moderator, Greg Orloff, our senior analyst and CIO, your host for this virtual conference on behalf of my team. Thank you for joining. Our co-founder, Karolina Rudinsky, will monitor the online channel, so feel free to send your questions in a chat line via the Q&A or using the social channels, LinkedIn and Twitter, leveraging hashtag ICS_IIoT. So Greg, welcome.
Thank you, Lucian, and greetings, everyone. Before we get into today's session, please allow me to give those who are joining us for the first time a little bit of background. IIoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the industrial IoT. IIoT World was recently ranked by K-Core Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Our mission is to help companies create a culture of innovation and connect the smarts. Industrial technology, manufacturing, sensors, and the CXO decision makers who seek these solutions. Today we have a dynamic panel with representation from Trend Micro and Applied Controls Solutions. In this 60-minute webcast, our speakers will share with us some of the most common cybersecurity issues that surface as IT and OT networks converge, as well as some of the practical tips and best practices to counter them. It's always interesting to see how others have done it before and profit from their learnings. It's now my pleasure to introduce today's panelists. Richard Koo has been involved in cybersecurity for over 28 years, serving as a threat researcher and engineer. He has managed and developed many security products and services across different customer segments and verticals. Richard is currently the Senior Vice President of Commercial IoT Business and Market Development at Trend Micro, a leading cybersecurity company in the IT space for over 30 years. Our second panelist, Joseph Wise, provides thought leadership to industry and government in the area of control system cybersecurity and optimized control system performance. He's provided support to domestic and international utilities as well as industries. Joe has prepared white papers on actual control system cyber incidents supporting NIST SP 800-53. He is supporting the NRC on the regulatory guide for nuclear plant cybersecurity. Joe has co-authored a chapter on cybersecurity for electric power substation engineering, as well as numerous articles. He has provided expert testimony to the House Homeland Security Subcommittee and offered control system cybersecurity recommendations to the Obama administration. In support of standardization, Joe has prepared a module for the IEEE Education Society and is a U.S. member to IEC TC 65 Working Group 10, the group that represents the United States at the International Electrotechnical Commission for Standards Development as it relates to the security for industrial process measurement and control, network and system security. So welcome, everyone. Richard is going to start us off today, and then we're going to dive right into our interactive dialogue. So Richard, would you like to say a couple words before we get going?
Thank you, Greg, and really appreciate it for everyone for attending this particular webinar, and welcome everyone, calling from, different part of the world. I appreciate you for being here. Yes, for the next 40 to 45 minutes, we will share some of the experience that we have learned from an industrial IoT perspective, specifically around cybersecurity. And we also share some of the business challenge, technical challenge, as well as some of the threat vectors and some of the best practice for organizations who are going through this transformation. So hopefully this will give you a guidance and some understanding as to what are some of the good best practice out there. So I think this is going to be and very, I will say, active conversation. So thank you everyone for joining.
Perfect. Thank you, Richard. Well, let me start us off with a question then, gentlemen. So from your perspective, what are the growing industrial threat landscape and industrial IoT attack surfaces?
Yes, Greg, let me start on this particular, question, right? And so let me walk through a couple slides to let people know what really happening for the last, couple decades in terms of the threat landscape and also the threat vectors. So these are some very large number, right, that actually are collected from Trend Micro Threat Intelligence Networks. And as you can see here, right, these are the number, the first number, the 48 billion plus. These are the threat that we block every year when it comes to malware attacks on the different industry and different verticals, as well as, across our consumer business, right? So this is a very, very large number. Right? That's 48 billion that we actually block every year through our, our network. The other number is the 250 million plus, right? This is how many endpoint and network device that we actually out there, in customer environment and, basically capturing all the information and sending it back to our threat intelligence network. So as you can see, we have a large and huge number of devices out there collecting all this data back. And then we also query about 2.5 trillion plus threat every year. Right, so this is a large number. Well, I remember the time back about 25, 30 years ago when we can actually count the number of threats, right, in our fingertip. And today it's just impossible, right, with this kind of number and this type of threat. This is a historical, or there are some notable cyber attack that really I was designed specifically for the industrial environment, right, and how it actually affect this type of industry, right? So you can see this is over the last, a couple of decades, you have seen this type of attack, and they are very specific to industrial environments. Starting in 2003, right, you have the Blaster, right, and then Startneck in 2010, and and then of course, followed by some of the very recent, like in 2014, where you have the Black Energy attack in Ukraine. And then I think, as many of you are aware about the Mirai attack, right, back in 2016, as well as the, Laka Goga, right? And then just in 2017, we also have the Trident or the Triconic attack, right, in the Middle East. And just very recently, right, we have the, TSMC, right, which is a semiconductor, out of Taiwan, also have been compromised by a ransomware and basically take down, the whole, fabrication, for many weeks. So as you can see, right, the threat and cyber attack in the industrial environment is real, right? So let me also have Joe comment on some of these, attacks.
Richard, thank you. One of the things I wanted to point out is arguably the first public control system cyber attack was in 2000 in Maroochy in Australia, where a disgruntled system integrator basically cyber attacked the sewage discharge valves and dumped well over 1 million liters of sewage onto the grounds of, in this case, a Hyatt Regency. And it was an interesting case because, again, this was a system integrator, not, the question became, was he insider or not, because he's the one who actually installed the SCADA. And there were also all kinds of if you will, forensic issues in terms of how soon they found them. There were also, what I found out later, some interesting legal ramifications, because they caught him on a traffic stop after the 46th time he had done this, even though they knew there were all kinds of, like I say, legal things that prohibited the authorities from stopping him earlier. But this was all the way back in 2000. And that type of attack has occurred since.
Thank you, Joe. Now let's kind of shift gear a little bit, right? And let's kind of drill down to some of the specific attack that, I just briefly mentioned over the course of the couple decades, right? You can see, right, specifically in 2010, right, you see the Iran.net, centrifuge attack, right? And this was a zero-day vulnerability that was taken advantage by the, adversary and, try to compromise some CME equipment, right? And the result of this particular attack is that it actually, many of the centrifuge were basically put out, operation, right? And it does cause some physical damage in some of this, environment, right? In addition to that, right, you can see in 2014, you also see the German steel mill attack, right, where the adversary actually access, office network using some type of APT attack, and then they were able to obtain or gain privilege and control of the production system, and from there they basically perform lateral movement to many of the other systems, and they were able to basically shut down and cause massive physical attack or damage into some of this environment. And then the big one that I think we all see is the, and hear quite a bit in the news is that Ukraine PowerPoint grid attack, right? Where, the attacker originally, tried to compromise the corporate networks on the IT side via spear phishing, right? And then once they're able to compromise the IT networks, it performed a lateral movement over the OT network and spend, a couple of weeks there and be able to gain access to some of the lower level, process control system, such as HMI machine or PLC system. And it was able to basically, take down some of the system by, modifying password and, perform a lot more type of denial of service attack, via the telephone line. And that can lead to many of these system down, and there were like about 200,000 plus people were on the blackout for several hours and days on this particular attack, right? And then of course just very recently, right, in 2018, 2019, right, we have this Taiwan TSMC attack where the attacker actually able to use the WannaCry ransomware and be able to compromise some of the fabrication plant, and they were shut down. So as you can see, right, what we're saying is that from a cyber threat perspective, specifically on the industrial environment, is real, and and so you just want to make sure that everybody is aware of that. Any comment you want to add, Joe, on this?
Yeah, a couple of points. The first is a commonality between both Stuxnet and Triton. And first, one other thing too. Obviously, people are aware that Stuxnet was Siemens. Triton was Schneider. So one of the things this says is this is not a problem unique to any one vendor. The second point, and I think this is really, really, really important, that was out of both Stuxnet and what needed to happen with Trisis, is these were cyber attacks to make damage look like malfunctions. So for a year, centrifuges were being torn apart and nobody ever considered it to be a cyber attack. The Trisis malware, in order for it to be effective, had to do a similar thing. They had to be able to compromise the operator displays, because like with Trisis, if the operator knew that the safety, the process was starting to be unsafe, he would trip the plant. So this is requiring that your displays be compromised. And there's one other point that goes back, and it ties to this, that occurred with the Ukrainian power grid attacks. And that's that the serial to Ethernet converters. This is where you go from the sensors, to the HMIs. And that, by the way, is a two-way street. You can go to the HMI or you can go right back into the sensors. And the serial to Ethernet converters were compromised and bricked in the Ukrainian cyber attack. And that's kind of how all of these, in a sense, tie together.
Thank you, Joel. Now let's talk a little bit about some of the ICF attack vectors or the threat vector that we have seen over the last couple of decades as we learn and experience some of this attack. As you can see, right, typically what we have seen in many of the attack is that an adversary typically will try to gain access to the corporate networks via the IT side. And then, of course, from there, they perform lateral movement across to the OT networks or the control system network. And then from there, they can basically take control and compromise many of the field devices, as you can see here. In addition, I think some of the threat vector we have started to see is that in many large enterprise customers, especially on the OT network, they're also starting to open up many of the level 0 and level 1, even level 2, to allow third-party vendor, right, to come in and perform maintenance and update to the software or to the application itself, and that also can create a threat vectors or create a vulnerability for the organization. So this is just one of the threat vectors that we have seen. Now, in addition to those vectors, here are some of the area and threat vector that we also seen, right? You can see that, there's a level of, attack that coming through can be done via communication protocol attack, web application attack, wireless attack, even software attack and server attack across a different environment, on the OT networks, as well as you're going to see some physical attack directly into some of the field control or field devices or safety system in the OT networks. So these are some of the example of, attack vector that we have seen and, also vulnerable for, many organizations. Now let's talk a little bit specific around the different type of attack, right? And the first one we want to cover was the, in 2010, the Iran centrifuge attack, right? And you can see here Stocknest, right? On November 16, 2010, the device of the, Iran centrifuge were affected, and about 8,400 centrifuge for uranium enrichment were affected. And, it also took them more than a year, right, to identify these particular attacks. Right? So this is a good example where having the ability to understand both the IT networks, the OT networks, and the knowledge about, the different type of protocol across different industry, both the IT, OT environment, and the knowledge on how the different type of attack vectors and threats, that can really help you to kind of identify, some of these attacks early on. And this is one example where it took them a long time to basically figure out what's going on this particular attack. Joel, do you want to comment on this?
No, I've not really. I've already talked a little bit, and hopefully we'll have some more open discussion on this. Okay.
And then, of course, we talk about the, Ukraine power grid cyber attack, and this really, back in 2016, right, as I mentioned earlier, right, and, this also had destroyed, basically, affect many, users across, the whole Ukraine, country. So this is that one example. And this is how it actually, affected, right? It basically, the malware compromised, IT network, perform lateral movement across the OT networks and basically take control of some of the, network systems or control system, and then work its way down to the different level within the organizations. And this one here, which is I would say probably the most popular type, and how it get into the network was basically the hacker connect through the network via a RDP, right? And then from there, from the RDP station, it connected to SIS, workstation, and they basically try to compromise many of this, system as well. So you can see these are just, and this also affect many of the safety system. And as Joe mentioned earlier, right, this was a system that was provided by Schneider Electric, right, and this also was compromised. And in many cases, right, in this particular example, the malware was able to get into the system. It took a long time also for the network engineer to actually discover that, the effect of the system was not anything related to the device itself, but was a malware actually, is causing it to trip some of the system and shut it down. So this is just an example where having a good knowledge in terms of the OT networks, different type of protocol, and also the threat in this kind of environment will definitely help you to address and hopefully discover some of these issues. Joe, any comments?
Yeah, this is a very, very, very important one because, as you'll notice what was said, Triton was discovered when the plant tripped in August of 2017. What we found out later is the plant actually tripped the first time in June. And at that point in time, the OT people hadn't seen any malware, if you will. And when they did the forensics of the safety module that tripped the plant, there was no malware in that module. What makes this so scary was the malware was in the engineer's workstation. It wasn't identified. And they restarted that plant with all of the malware still in the engineer's workstation and ran it for 2 more months before it tripped again and they found it. So this brings up an awful lot of questions, including the adequacy of forensics.
Yeah, that's a great point, Joe. Let me just jump in there for a second. I mean, this is probably going to open up a whole other level of discussion, but what are some of the business challenges of securing an OT environment?
Yeah, thanks, Greg. I think that's a very important question. And I think, let me jump to the next, couple slides. Let's talk about that, right? So let me share some of the, experience that we had as we, talking to many of our enterprise customers, specifically around some of the business challenge on the OT environment, right? Or some people call it the operational technology environment. And here are some of the things that we actually capture from many of these customers, right? So the number one thing that we see a lot is that there is a lack of governance, right? Or framework to really, bringing people together and be able to create a, I would say overall strategy across the IT or OT networks, right? So that seems to be kind of what missing, right? The other one is the lack of domain knowledge and skill set, as I previously mentioned, and how to address some of the, cyber security issue on the operational technology environment, right? Because we definitely, today, there's a lot of skill set on the IT environment, but on the OT environment, we definitely see a lack of, skill set and knowledge on, how to secure that kind of environment. Mm-hmm. In addition to that, right, the return on investment, right, it's very difficult to prove that or to show that to the C-level within the organization, right? So company and organization need to be to recognize that, return on investment in cybersecurity on the OT network is not always going to, be something that you're going to see right away, right? It's more like buying insurance to help you to make sure that if you ever get attacked, right, you can prevent that from happening, right? And then, of course, you have the unclear roles and responsibility across the IT OT networks, right? We talk about, for the last 30 years or so, I think organizations have been very focused on building the, I would say clear roles and responsibilities understand on the IT networks, but we don't have that on the, operational technology environment. And that relationship between the IT, OT, does not happen very much. And so hopefully with this kind of, conversation that we're having, will help to kind of bridge that relationship between the IT, OT, and make sure that there's a clear, roles and responsibility on how to address the cyber attack on the OT networks as well as IT. What we also see, is the level of legacy systems or environment in the OT environment, right? You can see that on the IT side, typically people will actually have the latest and greatest technologies and system, right? But not necessarily on the OT networks, right? Many of these organizations have implemented and they have those environments, set up probably for the last couple of decades. And many of these systems, like older version of operating system, older hardware, and they're very much, very vulnerable to attacks, right? And of course, the other big business challenge is typically what we are seeing is that, organizations tend to kind of take the profit, right? Over that of cybersecurity, right? Regardless if you are let's say the end users or a device manufacturer or platform provider, right? They want to get everything out there, make money, right? And then hopefully security, is not an issue, but that's not always the case. So this is some of the, I would say key challenge we see in the business environment when it comes to, OT network or how to secure that kind of environment.
So a lot of issues to surmount there. Now, those are some key points. Well, can you talk to some of the technical challenges then on the OT side of it? I think they're fairly straightforward in the IT, but from an OT perspective, what makes it difficult to secure?
Yeah, thanks, Greg. So as I mentioned a little bit, right, you can see here, right, these are some of the key, technical challenge we see on how to secure an OT networks, right? One is the shadow OT, right? And very much like on the IT side, you have a shadow IT. Nowadays, you have thousands devices connected to the, basic OT networks, and there are many unknown device, unknown connection, right? That's a big issue, right? And also many of these platform or system that connect to there, right? There's a lack of authentication, right? And that could be due to the flaw from the design or some implementation. And then, of course, you have the insecure protocol. Many of the protocol on the OT network are simply unencrypted, and it's all clear text. And then you have the unpatched system, as I mentioned, right? Many of the systems that sit on the OT networks, many of them are older version operating system like Windows 2000 or Windows XP or Windows 95, and we even see that. And many of these systems are very vulnerable and does not have any type of patch. Or in many cases, these organizations don't want to patch them because it's working and it's not necessarily, when it's working, they're not going to touch it. The other big one, I think, is the lack of security design features, right? I think on the IT side, we traditionally look at, when we build software, right, we think about threat monitoring, and then build security right into the application or to the OS or to the platform. But that is not always the case, or most of the time actually does not happen on the, OT networks and some of the many devices there, right? They don't look at security as a high priority. So, if lack of security design features also is an issue on the OT networks. Insecure third-party application OS, which I already mentioned, right? And then, not just on the IT side, but on the OT side, many of the traditional malware that we always think about not going to be able to affect the OT network. But as we all know, right, the more connectivity and the more complexity on the OT networks, then you want to start to see this type of attack like APT, ransomware, and state-sponsored type of attack that, also can be a big, I would say, technical challenge for the, OT networks. And in addition to that, right, these are two more here. Also, in many environments, especially in industrial networks, right, they are air gap, right? They're not connected to internet, right? And so it's difficult to basically address the, cybersecurity issue on some of this air gap environment, right? And here's an example where you might have a ship that actually out in the ocean, right? And, they're kind of isolated, or you can have a, in a manufacturing plant or an oil field, right? A rig in the ocean, right? These are air gap environment, and they are still very critical system. And how do you secure those, right? There's no way to connect it. You have to physically actually go there and be able to secure those type of environments. So that's a big technical challenge, I think, for many organizations. And of course, we talk about legacy systems, so we're good on that as well. All right, great. I think.
Yeah, Richard. Yeah, another question for you too along those same lines, because you've kind of highlighted a lot of the different aspects, but what are some of the differences and similarities between an IT and an OT network from a security standpoint? Yeah,
so this is I think a diagram that most of us have seen, right? And the difference between IT, versus the OT networks is that on the IT side, people typically, think about the confidentiality, the integrity, and the availability of the, system, the networks and stuff like that. Versus on the OT side, is completely the opposite, right? Availabilities, integrity, and confidentiality become more important, right? And I even say, that maybe availability should be more about the safety, right? So you can see that this is our traditional, I would say, security model that we have always been taking across the different environment, but on the OT environment is completely reversed, and the safety, the availability, and the integrity probably are more important when it comes to the securing the OT or network. So that's one big difference. And of course, here's some additional thing that we talk about, right? In the protocol, right? Protocol, on the IT side, you got standard TCP/IP protocol, and that include, authentication and encryption. However, on the, on the OT networks, right, TCP/IP protocol and lots of vendors specific protocol are not built with security. And some in many cases are clear text, right? How about network segmentation, right? They're typically on the IT side, we segmented by IT with firewall, and so forth, right? But on the OT network, right, segment by level, right? So if many of you, there's a reference model called the Purdue reference model, and if you look at this, right, and we're probably going to talk about that in a couple slides down, but the Purdue model basically allow organizations to segment the different type of, OT network architecture into a level 0, level 1, level 2, and level 3, and then how each system are actually put in place on this level, and how do we secure it, right? So we'll talk about that a little bit more. So that's one big difference. Threat, right? We got IT threats and IT OT threat on the OT networks are very similar. And typically in the IT environment, right, when an enterprise customer purchase, say technologies or systems, right, they typically anywhere between 1 to 3 years, right? That's kind of the life of the support for many of this system on the IT side. But when you move across to the OT network, right, many of the systems are typically long, support and use it for a long time, 10, 20 years. And that's what you're going to see on the OT network. So this become also a big challenge, as I mentioned earlier. Security patch, right? Typically, you're going to see a lot of organization, right, have a regular, I would say standard patch process and, time, that's set on the IT networks, right, and make sure the application operating system are patches. However, on the, OT network, as I briefly mentioned earlier, right, you really don't see a lot of patching happening, right? And in many cases, right, they are hardly apply any kind of patches on the OT network, right? And what are some of the impact, right? Event impact on the IT side, in general, right, you don't, I would say have people doesn't get hurt, right? And you probably, lost some data and stuff like that. But on the OT network, right, the impact can be big. It can be huge, right? The possibility of, people live are in, are there, and, the environment and the industry can be impact. So the impact between IT, OT actually are very different and how we look at it. And of course, you have the different type of protocol, right, across IT, OT network. There's a big difference, right? On the enterprise side, you got your traditional, standard HTTP, RDP, FTP, SMTP protocol across the different type of server, from desktop all the way up to the mail server and even to the cloud. Right, but on the OT networks, some of the protocol in the different type of system like PLC, SCADA system, HMI sensors or actuator, you are looking at different protocol like Modbus, S7, DMP3, and so forth, right? So you can see that the protocols are very different, and those are been around for a long, long time. So securing, on the IT side, it's much more simple because many of the product and solution today are really designed to support those protocol. However, on the OT networks, these protocol have been around for a long time, but also non-standard across different industry, different type of system. And so that can be also a big difference between these two type of environment, the IT OT. Great. And so I think
so there's a lot of points that you just made there. I just want to touch on some of this. I mean, I could see how an organization could easily become overwhelmed, especially if they're smaller, or even if they're a larger organization. But there's people that are working on this and they're working through it effectively. Can you share some of the best industry practices and also touch on some of the standards for ICS security?
Sure. So I would say, at least from my experience, right? Here are some of my best practice and recommendation for organization, right? And, when I look at, from a cybersecurity perspective, I always think about what are the 3 key pillars for a good cybersecurity strategy across both IT, OT environment, right? And the number one thing that I always stress to many of my customers is that having good is really about the people, process, technology, right? And people, right, you need to make sure that you have well-trained staff who is aware of and understanding the different type of threat and what's happening out there, in the world, right? And you need to make sure that you have the, professional and the people that have the skill set that is qualified to address and, define cyber strategy, right? And make sure that you train all your people to recognize and understand, and you have to have a culture of, I would say, a threat in mind. So I think, having good people with, good knowledge and good understanding of cyber, strategy and cyber issue is important. The other one is the process, right? You need to be able to create good, I would say, governance, right? Good management system, good security, practice and, frameworks, right? And to allow you to have that, in place so that anytime when you have an issue, right, you will be able to put this process in place in, on an organized way, and to allow you to address any issue that might come up, right? And then last but not least, the technology itself, right? You need to make sure that many of the technology that you implement on the OT network, usually, right, have to be test, verify, and validate, right? Not all technology can work on the OT network, right? I have seen an example where, organization go and, basically buying an IT product and try to deploy on the OT network. And, instead of solving the problem, it actually create more problem because the IT product wasn't tested or verified to make sure it worked on the OT network. So that's important, right? And, in order to deploy some of this technology, right, you have to have that people, the process, right, and the overall plan to really make this happen, right? So I think this is very important for people to understand and recognize, and don't. In many cases, when I talk to organizations, they automatically jump to the technology, right? But they forget about the people, the process, and I think these 3 are 3 key pillars I want people to understand as well. And here are some of the. If you look at the industrial, I would say evolution for the last couple of decades, right? You start at the industry 1.0, right? And then we move to industry 2.0 and 3.0, and now we all have industry 4.0. And you can see there, right? Based on the, on the left side, I have from low to high on the automation and connectivities. And on the bottom, right, basically is the business operation risk and environment complexity. And you can see through this mature, I would say, cyber risk model, as the industry moved from 1.0 to 4.0, right, you have an increase of visibilities, right? You can also increase your prevention, and you can increase detection, and you can increase your response, and you increase your collaboration, right? And that will help you kind of reduce some of the risk, right? So you can see here, when you look at this industry, every decade you have this big transformation or big change in platform industry, right? And by increasing some of this additional capability, it will help you to reduce some of the risk in the organizations. And here are some, I would say, good best practice industry standard that I think organization can follow or use as a guideline, right? And I typically go to the ISA 99, IEC 62443. This is the International Society of Automation. This is a good standard and framework to help organization, right, to start understanding on how to best secure, right, industrial control system. Right? And on the power industry, you have IEC 62351 or / a NERC CIP in the US. That is something good, I would say, best practice guidance. In addition, right, you also have the NIST SP 800-53, right? This is a good guideline that includes some kind of risk management framework, and it tells you what are some of the baseline and guidelines on how to create good cybersecurity control, cybersecurity strategy across the industrial environment. Right, so these are some of the good best practice standard and framework that I would recommend also people to look at. One additional thing that I kind of briefly mentioned, right, which is the risk management framework. And I think every organization, regardless if you're managing the IT side or the OT side, it's good to have a good risk management framework that covers both of this environment and be able to help you to identify, prevent, detect, respond, and recover from any type of threat. And hopefully with all this threat intelligence, it will help you to kind of predict what potential threat will be in the future, right? So having a framework like this, it definitely can help you to identify some of these threats in your organizations. A good sound and design foundation, right, from cyber strategy and cybersecurity control. As you can see here, basically I lay out kind of very high level, kind of the different level on the IT OT environment. You can see on the very top, right, this is where you have your traditional information technology or IT environment, and then on the bottom, right, you have the operational technology environment, and there you're going to have the different level where and how you can secure. And then on the left side, the different type of technology you can actually apply across each level or each, in the organization, and what are some of the risks. On the very top, you can see like, business operational disruption risk to, financial fraud to privilege abuse and stuff like that. So these are good examples of risks that you can actually see and how you can attack on each level. And then of course, you need to be able to understand the different type of threat, right, that can really affect the whole, every level within the, IT OT network. So having that good understanding, a sound foundation, it will help you to address some of these concerns. And
all right, Richard, so taking that into account then, if you've got the technologies, the risks, the threats, but what are some of the practical solutions from an IT and an OT perspective, to better understand how the industrial IoT can be secured?
Yes, thanks, Greg. So, I think let me kind of talk about some of the best practice solution and security control that I think it might be very applicable to many organizations, right? So this is the ISA 95 Purdue or reference model. And this is how I typically recommend people to use to kind of lay out the strategy and security control around this reference model, right? Because it may not be, I would say, for everyone, but each verticals or each vendor might implement differently, but this is a good framework and reference that everybody can follow when it comes to creating a cyber strategy or creating cybersecurity control for the industrial environment. And so what I have done was looking at what's happening for the last, couple decades and what's happening now, and I would say, create what I think it will be the best way to secure the, enterprise environment. And as you can see on this particular reference model, right, on the right side, you have your traditional information technology or the IT networks, where you have level, different, layer from endpoint, server, middleware to gateway, and then in the cloud. And then on the left side, you have your reference model, which I mentioned earlier on the previous slide, the OT operation networks. And that OT networks are also segmented into different level 0, level 1, level 2, and level 3. And within each this level, right, you actually can create security strategy or security control and apply to each level, right? So on the IT side, I'm not going to talk about that, but want to focus on mostly on the OT side and on the left side of the screen. And as you can see, right, what I have to also add is that I've seen many organizations are now adopting cloud and virtualization, as part of their overall, I would say, OT strategy, or, and so in that case, you also need to think about what are some of the things that you need to secure in the cloud as well. So from a security control perspective, I think there's many ways that we can do at the level 0, right? Now, in some cases, it may not be possible, because at level 0, these are the actuators, the sensors, the devices, which may not have a lot of, I would say, memory or disk space to allow you to do that. And also some of the systems are old, so it's difficult to do anything there. But if you're building new device from the ground and you have sufficient, say, memory or disk space, you definitely could secure this kind of environment as well, right? And so you can either build right into the device itself, or using other technology to allow you to, address that issue at that level. So there's quite a few security tools out there, right? Everything from, I think, secure boot that you can actually implement, or you can also, if you're building a system from the ground up, right, you can actually use some type of security, let's say SDK and binary you can build into the device itself. So that's a good area to think about, and how do you do that. And then when you move up to the next level, level 1 and level 2, right, you can also think about, all right, most of this system, right, PLC, DCS, HMI machine, these are very old system and might have old operating system or application. And so there's a couple of recommend that I typically provide to my customer, and that is you can actually look at purpose-built, lockdown product, right? Because in many of the system, you can actually lock down the system and you only allow the approved application to run in that kind of environment, right? So a lockdown product can be a very good solution, especially for those embedded Windows systems or Linux system where typically people don't patch or don't update, right, and worry about the potential of being compromised, or they don't want to have an impact in terms of performance. So a purpose-built, whitelisting product or lockdown product can be very, very good to use in that environment also. And of course, you have some of the air gap environment, right? Air gap can be a big issue as well for many organizations when it comes to securing them. So there's some certain type of, let's say, air gap security product that you can use to actually go from, your, physically take that type of, say, USB stick, and you can actually go to the system and perform the scanning, right? And then, of course, the next level up is the supervisory level, right? These are just your traditional, Windows systems, or maybe your data centers or your virtual environment, right? And many of the traditional, I think, product today on the IT side can also work, because this environment are very much running Windows and Linux. And so you can have endpoint product that can secure those. You can have server virtualization security product. And then between, the IT, OT, right? How do you make sure that, when something has been compromised on the IT side and you don't get compromised again on the OT side? So some type of networking firewall product or IPS product, right, that can sit and basically monitor all the east-west traffic, right, can be very important, right? And then, of course, we talk about maintenance people. We talk about people coming directly and, addressing, maintenance issue in level 0, level 1, level 3, or level 2. You can actually, make sure that you can, those systems that are bringing and connected to the networks are completely clear, right? So you can use some of the endpoint security solution there. Also some type of, USB type of, security solution. You can perform scan before allowed to connect to the, the network, right? And last but not least, in the cloud, right? So the cloud component is also very important. And as data flow from maybe the OT side into the cloud for better, I would say correlation or better analytics, right? And all the telemetry is going to be sent up to the cloud. And you want to make sure those, workload or those, systems are also secure. So some type of cloud security solution that can address, your virtual environment or your cloud workload, that can also be very important to think about. And of course, device connected directly to the cloud, in many verticals like healthcare, you also want to make sure that happen. I do also, I would say that as we see the industry evolve, right, you're going to start to see organization, especially security company, adding basically network device on level 1 and level 2, right? To help people from basically doing segmentation, at level 1 and level 2, and they don't have to deploy anything on the whole. So I think I will start to see what was say next generation IPS or maybe firewall product. That might move its way down to level 1 and level 2, where you can basically put that appliance product right in front of the PLCs or DCS system. Right, so these are some of the I would say best practice and guidance that I think we can you can look at and review. I think just a quick summary, right? I think it's important to make sure that your vision, your strategy, execution plan, right, includes cybersecurity as part of the overall strategy. A good security policies and governance, and end user education across IT, OT environment is, I would say, a must. And of course, we talk about the baseline security control and security framework, right? It should be deployed across, all layer of the organization on the IT, OT side as well. And I mentioned some of the standard, right? The 853, 10 or the 211 and, ISA, IEC 62443 standard for OT. I think these are good baseline, best practice that you can use. Make sure you do a regular risk assessment across different environment, right? To identify any type of vulnerabilities and make sure that, you have this thing, under control. And, establish some type of, security patch or update policy to address the vulnerability, right? And, follow a recommendation like IEC 6243-2-3, right? Which describes some of the requirement and patch control systems. And of course, develop a policy procedure that are consistent across both IT and OT environment. As I mentioned earlier, one of the biggest issues we see is that there's a lack of communication between these two, I would say, organization, and that bridge and that, I think relations have to be built. And, we last but not least, I think the education and training of your people is very important. Make sure they understand, and have the skill set to address cybersecurity, in your organization. So make sure that's clear understood, across all levels of the organization. So these are some of the best, I was guideline.
These are some great points, Richard. I don't want to cut you off, but I know everyone's going to get a copy of the presentation. So I think some of these summary key points, I just want to be cognizant of time. So we've got a tremendous amount of Q&A coming in from the panel. So if you're okay with that, I think we're going to transition into the question and answer point now.
Yes, let's do that. And we'll share the presentation with everyone.
Perfect. So as we switch gears here, I just want to remind everyone, I think you found the Q&A in the Zoom, it looks like, fairly easily, but if you're also submitting questions via Twitter, please use hashtag ICS_IIoT to send those in to us. And if we don't address everything live, rest assured we will carry this conversation over to social media and we'll get your questions answered there. And Richard and Joe will circle back with you. So let me jump into a couple of these. Okay, do IT security solutions have enough signatures to detect OT level attacks? This is a question from Vikrant.
Yeah, I think that, let me kind of do, I'll comment and then Joe can add. I do see that, on the IT side, definitely, we have the different type of rules and signature to address the many type of attacks. On the OT networks, I started to see, cybersecurity organizations start to now look at that, what are some of the vulnerability, what are some of the threats, right, and what type of attacks they're coming through, right, and started to develop product and, create, rules, a signature to address some of these attacks. So we definitely see that coming, and, some of them are already available today on the IT/OT environment as well. Joe, you want to add anything?
Yeah. What's missing in a lot of this is the focus is on malware. In the control system world, you're also very much interested, are you going to cause equipment to operate in a regime that could cause damage? And we really don't have quote unquote signatures for that because that's not malware. So there's a difference between worried strictly about the network as opposed to worried about the impact of the actual process. And we need to get a better handle.
Other question?
Got it. Here's one from Ravi. It says, Stuxnet modified the basic PLC program and it was not a very complicated attack. And he's wondering why it took them over a year to identify that. Any insight into that, Joe or Richard?
Yeah,
maybe I'll let you comment. Yes.
Yeah, let me give you a very clear point. The Siemens International User Group in 2008 had Idaho give a presentation on compromising the Siemens PCS7 systems. It was essentially Stuxnet. That was in 2008. Only nobody that walked out of that room was able to really understand the implications of what they were told. And I could tell you this, when Stuxnet was first found, people were talking about, I've never seen anything like this. How could this happen? We keep having situations, if you will. Aurora is another thing. People have known about out-of-phase conditions for 50 to 100 years. The concept of using them as an attack vector generally is not understood by the end users. This is one case where the attackers, in a sense, have a leg up. They're thinking evil thoughts. They're thinking of what to do, whereas the defenders are simply worried about don't have something affect me. But the point being, even when you're told what can happen, if you don't have a good context, you're not going to understand it.
Yeah, and I also want to comment that back to my question about the lack of domain knowledge and expertise, right, in the OT domain. And I think that's exactly one of the issues, right, where if you don't have a good domain knowledge on the OT networks in terms of the different type of protocol, how a threat vector, what type of threat vectors, and how the malware could potentially affect it. So in some of this incident, right, people only look at the physical device itself, but not aware of the attack using malware. And that's part of the reason why I think, it took a long time for people to find out about the attack. So I think, having a good, I would say, collaboration with the IT OT networks in the engineering on the OT side and also the network engineer on the IT side coming together and be able to look at some of the issue and, attack or from both ends, I think it will probably help them to address some of the thing much quicker.
It's 9 o'clock.
then they should and then a year later, right? So that's additional comments.
Great. I have another question for you guys. This is from Mohammed. It says the virtualization of IT networks is assumed to help in cybersecurity. How applicable is this to an OT or an ICS network system?
Yeah, so I'll add, I would say that we are starting to see many organizations are doing virtualization OT networks, specifically on the supervisory level, right? And even though you do virtualization and you do your own private data center, private cloud, right? Security will continue to be there regardless. I think if you virtualize or not, you always need to think about security. And make sure that you have the right security control that can be implemented across the virtualization environment as well as your non-virtualized environment.
I'd like to add one other point, and it goes back to what is a control system? And that is you've got all of these real pieces of hardware, sensors, actuators, drives, that a virtualized system is really not going to be able to address. And there's the tendency to just assume that they are correct or that they're not compromised. And this goes back to what Richard was saying. What's been missing up till now is being able to have adequate coordination between IT, OT, and the actual operational engineering. And we've got to have all three of those working together.
That's a good point, Joe. It's a very good point. Robbie's got a question for us too. It's more on the technical side. Is there any firmware testing for OT systems and devices?
Well, I think I'll add this, and maybe Joe can add more also, is that what we have seen out there, right, today, I would say testing and our firmware and device are available is done, right, in many of the systems that are being shipped out to the market. I think the big challenge was that security was never a thought process during that development, right? And so, yes, there's testing of firmware and devices out there, but unless you look at security and make sure that's a priority and implement that as part of your device or part of your firmware, right, then it doesn't really matter, right? Because you can test a great product, but you still have all these vulnerabilities, all the security holes, right? And so that's one comment I want to add, and Joe can maybe add on from industrial side as well.
Yeah, there's really two levels we're talking about. We're talking about legacy devices or legacy systems that do not have the ability to, if you will, sign firmware. Then you have the newer systems that have the capability of having signed firmware. And we've got to get to that point so that we know if firmware has or has not been changed, and also if it's been changed by whom. And we really need that, and it's not really there yet for legacy.
Got it. I'm going to take one more question just because we're approaching the top of the hour here in a couple minutes past. This one's for you, Joe. It says, what are companies doing to comply with the NERC CIP supply chain standards to verify software integrity and authenticity?
It's an interesting question. I was, this past Thursday and Friday, I was at the Naval War College where they had the cyber war games, and part of that dealt with supply chain. And there's, again, a couple pieces to this. One is you've got the NERC supply chain requirements, but they also are pretty limiting. One of the things that's limiting are things like sensors, actuators, and drives are not part of the supply chain requirements. Yet we just had these disclosures by one, in fact, almost all of our vendors have had counterfeit devices. And this came up literally last week in the war games. And there's one other aspect also. I'm kind of answering but not answering. And that is, you've also got people like Moody's who do the credit ratings. And they're looking at how secure are you from effectively an existential threat. So Moody's is not going to care whether you have or have not met the NERC supply chain requirements. They're going to want to know, have you actually secured your facilities so it doesn't blow up, or it doesn't, or in an electric case, you don't lose power. And we've got to get beyond that. I can tell you, like I say, this whole issue of counterfeit parts was brought up last week deliberately by some very, very, very senior people. And it's a very big deal because they are not covered by the NERC supply chain model. And that has to change.
Interesting. That's a great piece of insight and something to build on for the future for sure, Joe. Thank you. Well, I want to thank everyone for taking the time to join today. Stay tuned for other educational webcasts brought to you by IIoT World. Our next virtual summit is scheduled for September 10th, 2019, and it'll focus on AI in manufacturing. We have other sessions in the works for later this year that will focus on topics that range from industrial cybersecurity to how IIoT and artificial intelligence optimize industrial operations. And as our team heads out across the globe, you're welcome to secure briefings with our analysts and co-founders during the up-and-coming events over the next several months. A couple of these to highlight: Digital Industries USA, September 11th through 12th in Louisville, Kentucky; the SPS IPC Drive Show in November 26th through 28th in Nuremberg, Germany; and Energy Tech in Cleveland, Ohio from October 21st to 25th. Special thanks to our speakers, Richard and Joe, and to today's sponsor, Trend Micro, for this educational session. And if you'd like to learn more about their organizations, you can also meet with Trend Micro's team at Orlando for the ICS Cybersecurity Summit, September 24th to 25th. Another ICS Cybersecurity Summit, October 21st to 24th. That one's in Atlanta. And also Industrial IoT World, October 31st to November 1st in Atlanta. So if you're looking for something to do on Halloween, there you go. If you like what you've heard today, I encourage you to subscribe to our newsletter or YouTube channels and follow us on Twitter at IIoT_world. If you have ideas for future topics or feedback about today's session, please drop us a note. We'd love to hear from you. This concludes today's program. Once again, thank you for joining, everyone.